Millions of people around the world are affected by paralysis and reduced mobility, which limits their ability to live independently and participate in activities they enjoy. The client for our 2021 ME229 design project is an avid book reader but uses a wheelchair and has limited upper body mobility, which makes it a challenge to turn the pages of their books without assistance. Our project this term was to design a mechanical page turner which can be activated by our client with head movements, so they can read the books they love with little assistance. The development of our design began with research on previously existing devices with similar functions for guidance and inspiration, as well as standards and regulations from APEGS for insight on important engineering guidelines and safety focuses. For the ideation process of this project, each group member shared a design alternative for the device. The alternatives were evaluated with SWOT analysis and a ranking matrix. Because each design had valid strengths and weaknesses, we decided to create a new design that combined outstanding features of each alternative. Our final design is a two-motor wheel assembly that rests on top of the client's wheelchair tray. The client's book is placed on an adjustable support beam with clamps that can be adjusted to the thickness of the pages. A wheel rests on the top of the book pages and is fixed to one of the two motor shafts. The motor is then secured to a piston cylinder device which can raise or lower the assembly to the thickness of the pages. The motor switch is placed on a collar device which rests around the client's neck and positions the switch underneath the chin. When the switch is turned on, the wheel rotates and lifts the book page. Then the rotating arm sweeps under the lifted page and brings it over to the other side. The function of this device was evaluated with traction analysis. The wheel rests on top of the page, and when it rotates, traction between the page surface and the wheel pulls the page up. The maximum applied force before the wheel slips on the page was calculated to be 0.049 newtons, which is acceptable given the small size and light weight of our parts. The analysis influenced our choice of materials to enhance the function of our design. This project has allowed us to refine the foundational skills that we have learned in engineering design. We have improved our technical skills in hand sketching and learned how to model 3D parts on SolidWorks. We have also learned how to effectively cooperate and collaborate as a group in a remote fashion during the COVID-19 pandemic. Organization and communication between our team members were key components in smoothly completing deliverables and keeping the project on track with our timeline. The skills we have learned during this project will help us in future projects as students and as professionals in the future.